In this video, we are going to see about the electrical measurements under Unit 5. First, we see about what is measurement. Measurement means it is a comparison of unknown quantity with a known quantity. The known quantity means it is a predefined standard quantity. The methods of measurement. There are two methods of measurement. First one is the direct method and the second one is the indirect method. In direct method, the unknown quantity is directly compared with the standard known quantity. The unknown quantity is called the measurand. But in indirect method, an intermediate device is used. First, a transducing element which converts the quantity to be measured into an analogous form. So that analogous signal is then processed and then the end device represents the results of the measurement. So intermediate process is included in the indirect method. And now we see the characteristics of measurement system. So this performance of any measuring instrument is affected by several factors. Here we are going to see two performance characteristics, that is static characteristics and dynamic characteristics. First we see static characteristics. Static means constant. So here static characteristics refer to the characteristic of system when the input is either held constant or varying very slowly. For very slowly varying measurements are characterized by the static characteristics. So the static characteristics are accuracy, precision, sensitivity, linearity, reproducibility, repeatability, resolution, threshold, drift, stability, tolerance, range or span. Let us see these 12 characteristics one by one. First, accuracy. Accuracy means it is the closeness of the measured value with the actual value. That is, it is the difference between the measured value and the actual value. Actual value is also called true value. The difference is called the accuracy. And next, precision. Precision means some group of measurements that takes place and how much it is closer, and then which value is closer, that value is taken as a precision value. The third one is the sensitivity. Sensitivity means it is the ratio of change in the output to the change in input. When there is a change in input, there will be small change in the output also. The ratio between these two is called sensitivity. The fourth one is linearity. So linearity means the deviation, maximum deviation from the linear characteristics curve, that is called the linearity. Usually the curve is linear, but somewhat practically there will be some deviation. How much deviation occurs, that is the linearity. Next one is the reproducibility. In reproducibility, here how the degree of closeness, that is repeatedly measured. Here it is taken over the given period of time, but here the devices used or used for measuring is different. Under different conditions it is measured, that is reproducibility. In repeatability, it is similar to the reproducibility. Here this is also closeness of the measured value, but the measurand is measured under same conditions of measurement under same devices, using same devices. But here in reproducibility, under different conditions of measurement. That is the difference between the reproducibility and repeatability. And then next one is the resolution. Here in the resolution, if you are increasing some input, then for a particular change in input, then only there will be some change in the output. So that particular increment is called the resolution. The next one is the threshold. Threshold, if you are slowly increasing the input, there will be no change in the output. After the input reaches a particular value, then only in the output there will be some change. So that particular minimum value for the minimum change in the input value for the required change in the output, that is called the threshold value. Next one is the drift. So in drift, it is classified into three categories: zero drift, span drift and zonal drift. Drift means change. Suppose if this is the output and this is the input. If the characteristics, the nominal characteristics like this, and if in the zero drift, here the wave, the characteristics will be like this, parallel. So this is zero drift. And next one, if the span drift, means it will be change, there will be change in the span. So this is span drift. Zonal drift means actually the particular span of the point, particular span of the instrument, the drift occurs. That is called the zonal drift. The next one is the stability. So stability means it is the ability of the instruments to retain its performance throughout its specific operating life. You all know about stability, how it is maintained at a constant value. For without changing input, there will be the output should be maintained as constant. That is that ability is called the stability. Then tolerance. How much error is allowed? Suppose if you are measuring current 5 amps, so plus or minus 0.02 amps is allowed, means 4.98 to 5.02 amps is allowed. That is the tolerance value. For a measurement, a tolerance value will be given. The next one is the range or span. Range or span, each and every measuring instrument there is a range. Suppose if you take a voltmeter, if it is measured 0 to 30 volt, means that is the range or span. Up to 30 volt only it is able to measure. These are all the 12 characteristics, static characteristics of measuring system. The next one is the dynamic characteristics. So the dynamic characteristics refer to the performance instrument when the input variable is changing rapidly with time. Static means input is constant or slowly varying with time. Here input is varying very rapidly. So here the various dynamic characteristics, it's not static, dynamic characteristics are speed of response, measuring lag, fidelity, dynamic error. These four are the dynamic characteristics. So first, speed of response. And now this is the rapidity, that is how much fast the measurement system responds to the changes in the measurement quantity. If the input varies, how much fast the measuring system also measuring the measurement, how much speed it's measuring the measurement. That is the speed of response. The measuring lag. Lag means it is a delay. So in the delay, it is of two types: retardation type, time delay type. So in the retardation type, here after the change in the input, here the measured quantity, if you want to measure voltage, means the voltage will vary accordingly. So how much the measuring system begins immediately, just changing immediately, that is retardation time. Time delay lag means here if you are changing input, the output, if you are taking it as a voltage, outage varies. Here the measuring system will start after a dead time. For example, if the dead time is 2 seconds, after dead time, this 2 seconds only the measuring system will start to measure. So that is the time delay lag. Retardation type means immediately it will start to measure. Next one is the fidelity. Fidelity means here it is the degree to which the measurement system indicates change in the measurement quantity without any dynamic error. So without any error, suddenly the measuring system will changes in the measurement quantity. Without any error, the measuring system will measure the value. The last one is the dynamic error. It is also the difference between the true value and the value indicated in the measuring system. So but here this true value will be changed in time. Here in static characteristics accuracy, it is similar to the accuracy, but here it is varying with time. There it is fixed. So this is also called measurement error. So next topic is the static error. So static error, it is the numerical difference between the true of the value of the quantity and the value obtained in the meters or obtained by the measurement. Here there are three main types of static errors. What are the errors? Possible errors while doing measurement. First one, gross errors. Gross errors means that is due to the human mistakes. While reading the readings and then or in recording the readings, we used to see in the visually some errors will possible. That is called gross errors. Next, systematic errors. Systematic error means error due to the instrument, due to the aging or due to the environment or any defective parts in the instrument. That is systematic errors. Random error means here apart from gross errors, systematic errors, there will be some errors. We can't rectify these errors. Okay, but we can reduce these errors. That is called random errors. Thank you.